Air Force and actually large number of research institutions are doing computational fluid dynamics analysis on AWS, saving money and being able to ask what if far more often than they would have otherwise, using both commercial tools as well as open source tools like OpenFOAM. Galaxy cluster, probably many of the folks on the phone are using Galaxy to create clusters of servers with a preloaded set of biological tools, things that are used in genomics pipelines, for example. You can use Galaxy to create and manage the cluster, and then if you're using BioLinux as the operating system that's part of this cluster, it's very easy to get to a point where you in fact almost have a software as a service capability for uploading and analyzing data sets and correlating those to other data sets that happen to be stored in the cloud, potentially in something like S3. And now we're even seeing sequencing tools from companies like IonFlux that are taking DNA samples, analyzing those, sequencing them, and actually storing those results either purely in the cloud or both on-premise and in the cloud. And then if you have a facility that has a number of these machines, you can imagine that once that data is loaded in the cloud, you can very quickly grant access to the other folks that might want to take a look at that sequence and then ask some very interesting questions of it. I'm going to pause on this page for a bit to share some URLs. I'll also make sure that everybody has access to my presentation, so you don't need to copy all these down. The first link here, bigdata@hpc.com, is a pointer to a page that allows you to actually take a look at here. It walks you through the process of creating clusters, either using your own machine images or using pre-configured machine images that have been published by Amazon or by the scientific community at large. And effectively, by going through a few of these exercises, which would only take you a few hours, you could pretty quickly come up to speed with Elastic MapReduce, with building star clusters on Amazon Web Services, using some grid engine. Also walk through how to use our spot instances to create a very large cluster that has a low cost per hour that it's running, or even creating a cluster that might use reserved instances for static capacity, but then add additional workers using spot instances to get the results much faster at a lower total cost. If you wanted to learn more about specific use cases of scientific applications in the cloud, both of these links, HPC applications and the Spot and Science page, are interesting. If you want to read about our instance types, here's a URL for information there. And then the AWS blog is a good blog to follow. This gives you information about all the new services that we're rolling out on a fairly regular fashion. Typically, we'll see 2 or 3 announcements a week on this blog, and things that are, many of those are going to be very interesting to the scientific community. At this point, I'd like to say thank you for your time. Again, I'll try to make the presentation available to all of the participants. And I've left about 15 minutes for questions.
Okay, thank you very much, Jamie. Some great stuff going on at Amazon there. If anyone has questions, please post them to the chat if you're listening on the stream. And then folks who are joined to the H323 session, feel free to chime in. Jamie should just hear you.
Great. And for the chat session, which topic should I be joining? Is this the VSCSE general?
Yeah. Let's put that in the general chat. Yeah. If you have questions for those sites viewing the stream, post your questions in the general chat. And Jamie, you're monitoring that then?
Yeah. Take a look at it. Yep.
Okay. Any questions from the H323 sites? All right, well, we're not not seeing too many questions, so we'll.
We had
Oh,
one.
wait, we do have a question.
Yeah, I think it's taking folks to connect. So the question here is, can AWS virtual clusters support distributed file systems like GPFS or Lustre? Yeah, absolutely. And so we have customers that are building these out both on our HPC instance types as well as the standard instance types. But I think the HPC instance types are a better fit for this. So we have partnerships with Red Hat, who now owns Lustre, but there's also public images that have been created using Gluster. We've seen deployments of GPFS as well. Typically, what customers are doing is either using Elastic Block Store as the block devices underneath their cluster and creating either distributed replicated clusters or even geo clusters that span multiple regions. Recently, now that we've launched the high I/O instance type with the SSD volumes, we're seeing our customers build really high performance storage clusters that are intended to support the clustered compute workloads. And if you want guidance in getting that up and running, feel free to contact me directly. We have one of my colleagues that's a couple of rows down, who actually did quite a bit of work in the development of Gluster and a good resource for us. Okay, the next question is, does Amazon switch off its computers when they're not used? So we don't turn off or I don't know if we even talk about actually what we do to our servers when they're not being used, but generally what we do is if you think about Amazon's roots, Amazon.com's roots, we're a retailer and we're used to running with very low margins. And in the cloud, the way that this applies is that we actually run with a thin buffer of servers that we keep online that aren't being used at any given point in time, but we're doing our darndest to make sure that those also get used. So, vast majority of our servers are always in use, and thanks to the law of large numbers, as we've grown the size of our fleet around the world, what that means is that at any given point in time, because there's so many diverse workloads coming from so many different users, we're able to keep our servers very, very heavily utilized. And the spot market is intended as a way to ensure that those servers that would have been sitting idle don't sit idle. So there aren't many times that our servers aren't being used. And then a question about the links not available in the PDF that was shared previously. I'll make sure that we get the latest version of this deck to you so that you have access to each of the links that you now see on your screen. Another question is there a fee for data transfer from S3 and EBS to the cloud and vice versa? Or is it free? Yeah, there's no network bandwidth charges for data transfer within the Amazon cloud, assuming that you're operating within the same geographic region. There are fees for transferring data from servers in the cloud out of the cloud, or from S3 directly out of the cloud. And there's also no fee for transferring data into the cloud. All of this is published on our website. If you go to aws.amazon.com, look at any of our services. All of the pricing is publicly available. Some of our network egress charges, that's the only time you're going to be charged is when you're transferring data out of the cloud. Network egress, we charge at a sliding scale too. So if you're transferring a little bit of data, it's not going to cost you anything. If you're transferring a moderate amount of data, it'll be more expensive per gigabyte than if you're transferring large amounts of data, where in aggregate it'll be more expensive, but your cost per gig will start to drop. And yes, I'll share a link to the slides. And then finally, I'm curious how I got my start working with AWS and scientists. Thanks for asking the question. My undergrad is in marine science and biology, went to the University of Miami, and one of my first projects there was to work on data normalization for biological oceanography. I have a researcher who was working with data sets, with satellite data sets to try to predict primary productivity in the ocean by looking at the spectrum that was being reflected from the ocean, and then using ground truth data from ships that were doing transects to improve the accuracy of those models. Over the course of that work, I saw that there was need to come up with ways to take data sets that were collected using many different techniques and try to normalize that. So there's always been a personal passion in trying to combine computer science infrastructure technologies with scientific applications. Moved to Seattle a kind of stumbled into a role at Amazon, and then about 4 years ago started working with the cloud computing organization. Favorite customers are the scientific community, and I see tremendous challenges that we can help address with projects like Large Hadron Collider, CERN, that will require that cloud providers and other organizations develop infrastructure capabilities that don't exist today. And I'd like to be part of the organization that helps to make that possible. Any other questions? Okay. Well, with no other questions, I wanted to say thank you once again. Really appreciate the opportunity to address this crowd. I hope that this has been a good use of your time and you've learned something. Don't hesitate to contact me if you have any questions and want to follow up on this.